All right, so we got a kid on a Ferris wheel rotating 4 times each minute. Let's start with this right here. 4 times each minute. What can we get from that? 4 times each minute, we can get the angular velocity, right? So they're basically telling us 4 revolutions per minute. Is that an angular velocity? Yeah, totally. Now I'm going to convert this to radians per second. So when you convert this to radians per second, we get 0.419 radians per second. How did I do that? What's a revolution? 2 pi radian. What's a minute? 60 seconds. Okay, so just a conversion. All right, so we now have an angular velocity. We know the angular velocity is 0.419 radians per second. So angular velocity of this wheel, 0.419 radians per second. Okay, they give us the diameter of the wheel, 18 meters, but we care about the radius. So the radius of this wheel is 9 meters. Okay, so first question, what's the centripetal acceleration? So centripetal acceleration equals v squared over r. Now, one of the equations for v, because this v is a tangential velocity, one of the equations for velocity is you go angular velocity times radius, right? And when you're using that equation, this has to be in radians. Okay, so you take this equation, plug it in up there, so you go angular velocity times radius squared over radius. So this gives angular velocity squared times r, which is another equation for centripetal acceleration. So plugging into that, so our angular velocity is 0.419 radians per second squared. The radius is 9 meters. This gives a centripetal acceleration of 1.58 meter per second squared. Okay, that's the answer to A. Okay, B, what force, magnitude, and direction does the seat exert on the child at the lowest point of the ride? Okay, so we're focusing down here at the lowest point. So let's say, like, here's the seat, and then here's the kid sitting on the seat, right? What are the forces on the kid when the kid is like right here at the lowest point? Well, you got mg down, you got normal force up, right? Those are the 2 forces on the kid. So and for circular motion, always make the center positive. The center would be straight up. Always make the center positive. So when you sum the forces, you get normal force minus mg equals ma. Sum of the forces always equals ma. What's this a right here? It's a centripetal, and which we know, right? This centripetal acceleration is true everywhere, right? Well, when you're on the edge of the wheel, because it's rotating with a constant angular velocity. That's the centripetal acceleration at all points. Okay, so what you do is you take this. We're solving for normal force, right? It wants the force of the seat on the child. What's the force of the seat on the child? What's the force of a surface holding an object up? The normal force. What they're asking for in part B is the normal force. Okay, so you solve this for normal force. It's going to be equal to ma plus mg. That's the centripetal. So this is going to be ma plus g. This is the a right there. That's the centripetal acceleration. So you plug the numbers in. You get a normal force equal to 455. And then what's the direction of the normal force? They want direction also. 455 newtons, which way? To the center. The normal force points straight up to the center. Okay? All right, question C. So question C, what force does the seat exert on the child at the highest point of the ride? So now we're focusing up here. So here's the seat. Here's the kid sitting on the seat right here. So what are the forces on the kid? mg down, normal force up. Remember, the center of the circle is always plus. Where's the center of the circle now? If you're focusing at the top of the wheel, which way is the center? Down. Why do we make the center positive? What always points to the center? The centripetal acceleration. Centripetal acceleration is always to the center, so make the center positive. Okay, so we sum the forces. So now it's going to be mg minus the normal force, because the normal force points away. equals ma, where that's centripetal, right? And keep in mind, do we know the centripetal acceleration? Yeah, it's 1.58. Okay, so solve for normal force. The normal force is going to be equal to mg minus ma. Okay, so then factor out the m, g minus a. The a is 1.58. Gravity is 9.8. You plug the numbers in, and the normal force is about 329. Which way? Which way does the normal force point? Straight up, away from center. Straight up, the normal force is pointing away from the center of the circle. All right, and the last question is the trickiest one. The last question's the trickiest. Okay, so now we're focusing, what force does the seat exert on the child when the child is halfway between the top and the bottom? It's like right here. So look, here's the seat. So we're doing this point right here. So there's the seat. Okay. Here's the kid sitting on the seat. So what are the forces on the kid? Well, mg down. Now look, the force of the seat, there's a y component and an x component. Is the seat holding the kid vertically? Yeah, so that's going to be normal force. We'll call this force of seat. Force of seat y. And then, is the seat keeping him from sliding off? Yeah, because what if this seat were covered in butter? What if this seat were covered in butter? As the kid goes around the circle, what would happen? He'd slide off. So there has to be force of seat x, right? Okay, so let's solve these. Summing the forces x, what's the only x force? Force of seat x. Look at that, points to the center, right? So that's equal to ma, or that's the centripetal. Okay, sum the forces y. We have force of seat y minus mg, and then these guys are just canceling each other, right, to 0. So what you do is you go like this. Solve for the force of seat y, which is just equal to mg. Force of seat y is going to be 392. Okay, and then solve for the force of seat x. The force of seat in the x direction, centripetal acceleration is still 1.58. So this comes out to be 63.2. So now, what's the total force of the seat on the kid? It's going to be at an angle, right? So this becomes a vector problem. The force of seat x is 63.2. The force of seat y is 392. So now what do? You do Pythagorean theorem, and you get 397. And that's the answer. The total force of the seat is 397. And then you also want this angle, right? Using inverse trig, that comes out to be about 80 degrees. Okay?